Hi guys, in this video we're going to learn about experimental probability, and so in front of you can see a formula in the purple box. Now this formula is for how we calculate the relative frequency, and the relative frequency is calculated after we complete an experiment. So what I'm going to do is I'm going to flip a coin 300 times and I'm going to calculate the relative frequency of obtaining a head. So let's have a look at the results. So what I'm going to do is use randomorg.com. So I've got a coin generator. Let's flip the coin 5 times and count how many heads we've got. Got 1, 2 heads. So what I'm going to do is record the results in this Excel spreadsheet. So I'll just move the screen so you can see everything. Hang on, it's just being difficult. There we go. Move over. Right, so we got 2 heads. So I'm going to put 2 in there. Now what I've actually done is I've got a relative frequency calculator, which is actually taking the number of successes out of the number of trials. So this number here, 0.4, is 2 divided by 5, which you can see here, 2 divided by 5. Now ignore all of these numbers down here. These obviously is just Excel calculating things because it's expecting numbers to be placed in here. So I'm going to repeat this several times. Let's just do it one more time with you. So I'm going to just flip again and count the heads. So there we go, we've got 1 head this time. Now I'm just going to put 1 in there, and I'll continue the experiment and pause the video. Now, as you can imagine, after 300 flips of the coin, I've got all my results recorded here, and you can see them all now. Our final relative frequency ended on 0.506 recurring. Now, what I ended up doing was actually graphing the results of what my relative frequency looked like. So I'll just bring that in here. Obviously, my graph should be labeled. I just haven't had time to label that, so I'll do that in a second. But let's have a look at the relative frequency. So the relative frequency is on the y-axis, and you can see that the relative frequency started sort of bouncing around all over the place. It kind of was very inconsistent for the first 100 trials. And then after the 100 trials, it started to come down, and what's happened by 150 trials, it's settling more or less. It's still going above and beyond slightly. If we could zoom in a bit on that, I don't think it'll let us zoom in, but we can see that it's finally settling around the 0.5 mark, which is what we expect. So let's just have a look at what the final result was again. It was 0.5 correct to 1 decimal place. Now the theoretical probability of flipping a coin is 1 out of 2, which is 0.5. What we're actually finding is for the more trials we do, the more likely it is in an experiment that it's going to creep closer and closer and closer towards what we expect in theory. So the relative frequency should match, with only a large number of trials, the actual theoretical probability. Now, if I reckon I did more trials, maybe I could do another 300, I don't think we would see this bouncing around that we saw at the start. It would continue to settle around the 0.5 mark, which is what we expect. Once you've worked out relative frequency, we often use this formula here called the expected number. The expected number is basically based on the probability. Now, we'd assume if it was an experiment that the relative frequency would replace the probability here. So sometimes we use relative frequency, and obviously you multiply that probability by the number of trials that are going, or the sample, depending on what you're trying to find. So I'm going to do an example here where we use the actual probability, and then I'll do another one when we use the relative frequency. So on a fair dice, how many 6s are expected if it's rolled 312 times? Okay, well, first we need to know what the probability of rolling a 6 is on a dice, which is 1/6. So the expected number then is going to be 1/6 multiplied by the number of trials that are being performed, so that's 312. And if we calculate that, so we've got 1/6 multiplied by 312, we get 52. So we would expect 52 6s to be rolled. Now let's have a go at another example involving relative frequency.